Hello everyone, I am Adetunji, your physics tutor. Welcome to your physics classroom. In this video, we shall be talking on understanding elasticity. Take a look at the content. Unit 1, Introduction to Elasticity. Unit 2, Demonstration of Elasticity. Unit 3, Extension Calculation and Hooke's Law. Unit 4, Bullet Points. These are the points we shall be discussing in the next few minutes. Make sure you watch the video to the end and answer all the questions in it. Introduction to elasticity. Looking at your screen, you are seeing spring, mass, and stick. From your previous knowledge, what can you bring out and relate to elasticity? Here we shall be using physics concepts to explain spring and stick in relation to elasticity, Hooke's law, and calculations. I want you to think and comment. Mention two differences between a spring and a stick. Pause the video, type your answer and your name in the comment below. Elasticity is the ability of a material to return to its original shape after being stretched or compressed. We have a lot of elastic materials around us where we live, but common example or common elastic materials, we have springs, we have rubber bands, we have elastic ropes. When you compress rubber band or when you stretch, it needs to return back to its position. Also, springs and elastic ropes, when you compress them or when you stretch them, they will also return back to their original position, which shows that these mentioned they are examples of elastic materials. But what about whenever you have materials when you compress or stretch and it cannot return back to its original position? We call such material non-elastic materials. Such material is called non-elastic material, and here we have examples. We have wooden sticks and we have clay. We have a lot of examples just to mention few. Unit 2, Demonstration of Elasticity. Here we'll be using spring, masses, and spring balance in addition with meter rule, rotor stand, and some other things to verify and to bring elasticity that we are discussing to our practical. I want you to observe the spring, how it will behave when the weights are added to it. The first thing you need to check is that you need to measure the length of the spring, which I will show us right now before the load, and likewise we need to know the length of the spring when the load is applied. The observation you notice there, you tell me. Here on your screen, we have two diagrams, one showing a spring without a load and the other one showing a spring with load. We can see very well that the first diagram showing a spring without a load measures a distance on the meter rule from A to B, while the one with a load has measurements from A to B, B to C, and C to D. What do you observe? What happens to the spring when weights are added? Pause the video and type your observation in the comment section. I want to let you know that when the load is not applied on a spring, the measurement you take on that particular spring, that you can call the length of the spring, we call it the original length of the spring. When the load is applied on the spring, it has the new length. Again, when the load is applied on the string, it has the new length. Unit 3, Extension Calculation. What is extension, or how do we measure extension? Extension simply means the change or the difference between the new lengths and the original lengths. Extension simply means the difference or the change between the new lengths and the original length of a particular elastic material. In this example, we were given the original length as 10 centimeter and the new length, that is after the load has been applied on the spring, as 16 centimeter. To now get the extension, according to what we said earlier, that extension is the difference between the original length and the new length. The formula for extension is new length minus original length. Now that we have been given that our original length is 10 centimeter and our new length is 16 centimeter, extension will now become 16 minus 10 equals to 6 centimeter. That is the extension of that spring after the load has been applied is 6 centimeter. Hooke's law states that provided the elastic limit is not exceeded, the extension of the spring is directly proportional to the load or force applied. That is, the higher the load, the higher the extension. That's what he's talking about. And mathematically, F equals to KE, where the K is our spring constant or elastic constant, and it is measured in Newton per meter. Here we have an example to back it up. We have a load of 2 Newton and the spring extended by 0.04 meters. To now know the spring constant, we need to divide 2 by 0.04 meter, and it gives us 50 Newton per meter as the spring constant. Now test yourself. Bring out your book, your pen, because you have been listening to my discussion for the past few minutes. Now is your time to be assessed. I want to know how far you've understood what I have taught you. Bring out your book, your pen, and answer the questions below. The question says, a spring stretches from 12 centimeter to 18 centimeter under 3 Newton force. Question 1. What is the extension? Question 2. What is the spring constant? Pause and type your answers in the comment section. I'll be waiting. Bullet points. Unit 4. From our discussion so far in this video, what are your takeaways? We talk about elasticity as the ability to return to the original shape. We talked about extension as new length minus original length. We stated Hooke's law, which we find the formula as F equals to KE. Likewise, a question was asked about spring and stick. To let you know, one of them is flexible and one of them is rigid. Who is flexible? Which one is rigid? This is a graph to show the relationship between the load or force and the extension. According to that statement of Hooke's law, we say that the load is directly proportional to the extension. We can see the line of proportionality, and at a particular point we have something called elastic limits, and from there it will get to a point whereby the spring also will no longer be elastic again, that it will deform, it will change its shape. Try to watch all our videos and click the next video. Check our playlist, pick up videos on topics in physics, which I believe you really enjoy them. Our YouTube channel still remain at Estimator Adetunji. Please do well to subscribe, turn on your notification button, like and share our programs with your friends. Thank you. Bye. See you in the next video.